We are going to have a look in this lesson at special angles. Now, I hope you appreciate that this triangle here is equilateral. An equilateral triangle is an equiangular triangle, which means this must be 60 degrees here, 60 degrees there. Because this one is bisected, so each will carry 30. Now, if you look at triangle, let's call this D. If you look at triangle ABD, triangle ABD can be drawn as this. That is your D there. There's one here, 60 degrees there, 30 degrees here, a right angle there, a right angle there. So this side here is 2 units, one here, and we need to get Y, this what that value is there. Now, on this triangle here, that is the one on the left, we will have, because it's a right angled triangle, by theorem of Pythagoras, two squared, which is the hypotenuse squared, is equal to the sum of the squares of the two remaining sides. The remaining side will be this, BD and AD. That is AB squared is equal to BD squared plus AD squared. The square root of 2 is the square of 2 is a 4. The square of 1 is a 1. And we have Y squared here. Transposing the 1, it's going to be 4 minus 1 is equal to Y squared. That is a 3 is equal to Y squared. Therefore, the root of 3 will equal to Y. The root of 3 will equal to Y. So, means the side here is equal to the root of 3. Therefore, we can say the sine of 60 degrees, by definition, sine is opposite side to the angle on hypotenuse. The opposite side will give you Y, which is root 3. The hypotenuse is 2. And then we can also look at the sine of 30 degrees. By definition, sine is opposite over hypotenuse. The side that is opposite to 30 is 1. The hypotenuse is 2. We can also get the tangent of 30 degrees. And the tangent of 30, by definition, tangent is opposite. Tangent is opposite over adjacent. I said the word adjacent means next to. So the side that is opposite 30 will be 1, and the adjacent side will be the root of 3. Equally well, you can get the sine of 60 degrees. the cos 30, the cos of 30. Now I want us to have a look at the sine of 90 degrees. By definition, sine is opposite over the hypotenuse. The side that is opposite to 90 degrees here is that side. And that side is 2. And the hypotenuse is also 2. Same 2. So the answer is 1. Therefore, the sine of 90 degrees, the sine of 90 degrees is equal to 1. All right. Now, we can draw another one, another triangle. This side, you are going to draw an isosceles triangle. We're going to draw an isosceles triangle. We're going to draw an isosceles triangle. You still have your right angle there. So 90 degrees there. This will be 45 degrees. That will also be 45 degrees. And then one here. By Pythagoras, this will be the square root of 2. Now, here, the sine of 45, the sine of 45 is opposite. The hypotenuse is the root of 2. And the cos of 45, by definition, is adjacent over hypotenuse. Adjacent to 45 is 1. The hypotenuse is root 2. So the sine of 45 and the cos of 45 are equal. That's what you have. Now let's have a look at simple exercises where you are given fractions like the sine of 45, let's say squared, minus the sine of 90, say plus the sine of 90, divided by the cos squared of 30. Let's cos square of 60. The cos square of 60. The cos square of 60 plus the sine square of 30. This, now the sine of 45 is that. So note that the sine squared 45 degrees is the same as the sine of 45 multiplied by the sine of 45, and this is sine squared 45 degrees. We only square the ratio. You don't square the angle. You only square the ratio. And then this here, or this here, can be written as, let's undo that and see what this can be written as. The top one there can be written as the sine this can be written as the sine of 45 degrees squared. But this is written as the sine squared 45 degrees. So you realize that what is squared there is the ratio, the trig ratio sine, not the angle there. So you'll appreciate that once more, if the sine of 45 is 1/2, and then this is 1/2, so sine squared 45 is equal to 1/2 squared. The sine of 90 is a 1 on the previous page. The cos of 30, let's go back to this page and look at the cos of 60. The cos of 60 degrees by definition is adjacent over hypotenuse, and that gives you a half. Then you can go to our table. For the cos of 60 is going to be 1/2 squared. And then you can go back to our diagram there and look for the sine of 30. The sine of 30 is a half once more. We have 1/2 squared. This gives us 1 multiplied by 1 is a 1, √2 multiplied by √2 is a 2. 1 half squared is a quarter. Half squared is a quarter. This is 1/2. A quarter and a quarter gives you a half. This can also be written as 3/2 divided by 1/2, which is equal to 3/2. Then we change that into that. And if we do that, we also change the fraction in turning the denominator into a numerator and the numerator into a denominator. That will be 6/2, which is equal to 3. That is equal to a 3. Now, let's look at another example. Another example. If you have the cos squared 30 degrees plus the sine squared 30 degrees. This, if you go back to our previous page, the sine 30 is a half, and the cos of 30, we can also get the cos of 30. The cos of 30 degrees, cos by definition, is adjacent over hypotenuse, √3/2. Then you can go to our page. The cos of 30, we said that is √3/2 squared plus the sine of 30 is a half squared. Can go back to our initial phase. The sine of 30 The sine of 30 is a half. The cos of 30 is root 3 over 2. Now let's look at that. I said root 2 times root 2 is equal to 2. And now we are faced with root 3 squared, which is equal to the root of 3 multiplied by the root of 3. If we remove the radical sign, the x to the power half multiplied by 3 x to the power half. If you have x n here to the power 5 there, this is x 5 to the power 1 over n, and that will give you x 5 over n. The same thing here. The square root is a 2, there's a 2 there. Now the bases are the same, and the laws of exponent dictates that if you multiply powers and exponent and a base is a power, if you multiply powers that have the same base, you add the exponent. So we write one base and we add a half plus a half will give you a whole, which is 1. We will have 3 to the power 1, which is 3. So that's what you have. So the root of 3 squared is 3. The root of good squared becomes good. So this is what you have. So that's going to be 3. The root of 2, the square of 2 is 4. And the square of 1 is 1. The square of 2 is 4. Now you see 3/4. Now the base, the denominator is common there. We write 3 plus 1. That gives you 4 over 4. And that will give you a 1. So that's what that gave us there. Okay. Now we will go take this further in the next class, where we shall look into application of the special angles. Now, on our two diagrams here, we have 30, we have 60, we have 90. Now, we are going to have, we can say, we looked at 30 degrees, we looked at 45, we looked at 60, we also looked at 90 degrees. We can also look at 0, whereby the sine of 0 is equal to 0, but the cos of 0 degrees is equal to a 1. So you have 0, 30, 45, 60, and 90 for now. You can also go to 180, but that's not for this lesson. Hope you enjoyed. If you have any question. Okay.